Experiment, you'll need a kettle, a scale, at least 2 beakers, and some salt. You also need 3 water bottles, something to stir with, duct tape to label the water bottles, and a freezer. And don't forget something to measure with. In this case, we used a meter stick and string. We have to measure just in case the water bottles expand, but in this case, it's more about solidification. First, we measured the widest circumference of each water bottle with a piece of string. We measured in centimeters using a meter stick, but you could use a ruler too. Then we took our beakers and measured one with 20 milliliters of salt and another with 100 milliliters of salt. Boil water and then let it cool to room temperature. Make sure you boiled enough water to fill up 3 plastic water bottles to the top. By now you should have water in one beaker that's mixing with 100 milliliters of salt, water in the other beaker mixing with 20 milliliters of salt. Pour each beaker with salt and water into different water bottles. Then get another water bottle and pour pre-boiled water into that one. Fill all the water bottles to the top with pre-boiled water. Label the water bottles 1, 2, and 3 and label them 1 with no salt, 2 with 20 milliliters of salt, and 3 with 100 milliliters of salt. Then take each water bottle down to the freezer and place them in there for a day. The next day, observe the water bottles and measure how much they expanded and solidified. Record all this information on a graph or table. Find the amount of expansion by subtracting current circumference to the circumference before. Record this also on a graph or table.
So we have 3 water bottles. One water bottle has no salt, one water bottle has 20 milliliters of salt, and the other water bottle has 100 milliliters of salt.
We left the water bottles in the freezer for a day, but when we took them out, there was unexpected results.
Instead of just freezing, the water bottle with no salt turned into a very, very clear ice with no air bubbles in it. The water bottle with a little bit of salt turned into ice as well, but there was lots of air bubbles and cracks inside of it. And the water bottle with a lot of salt, it didn't freeze at all. It was still liquid, yet it was not as clear as a water bottle without any salt.
Woo! Hey guys, hey, can you do that? Oh yeah, okay. Hey 6th graders, today we're going to do an experiment with salt, water, and freezing. We're finding out if the amount of salt in the water bottles affects the result of water expansion. Ta-da!
You also need to start cleaning up.
That's good. Why am I 2 seconds away from? Ow! Just go. Let's go. Let's go.